Good morning. In the last lecture, we have discussed about what is a mechanism, what are the inversions of a mechanism in case of quadratic cyclic chain. In that previous case, which we have taken all four turning pairs. We have taken a 4-bar kinematic chain with all four turning pairs, and we have seen various inversions that we can obtain by fixing one of the links in that kinematic chain. And we have also discussed about Grasheff's and Grubler's criteria in the earlier classes, and today's lecture our focus is on inversions of single slider crank chain. So it is a 4-bar kinematic chain, or 4 links it consists of. Out of these 4 links, one is a sliding pair. Okay, so this is inversions of single slider crank chain. The basic mechanism consists of 4 links, and in those 4 links, what are the various pairs and what are the various types of motions that we are obtained. Let us first observe, then we will see what are its practical applications. So this is the model for a single slider crank chain. Here you can observe there are 4 links: link 1, link 2, link 3, link 4. So there are 4 links, and these 4 links are named with a different naming based upon how they operate. So in this mechanism, link 2 is called crank. Recall in the previous lecture when we discussed about what is a crank. A member which can rotate for 360 degrees is called crank. So by keeping that in your mind, you can see here in this mechanism, the link 2 is able to complete rotation. That is why it is called crank. Then link 3 is concerned, this will have both rotary action as well as reciprocating action. So as this crank rotates like this, then this coupler, with the terminology which we used earlier, the input and output links are connected by a link called coupler. So keeping that in my mind, I said link 3 is a coupler. So coupler, say this is the position here now, then the slider will move like this, and the coupler will revolve as well as reciprocate. So it will have 2 motions named as rotary motion and reciprocating motion. And finally, the link 4, which is called slider, so this reciprocates. Okay, so if you look at here, with respect to pairs are concerned, we have 3 turning pairs and 1 sliding pair. Observe here, this is 1 pair, and this is another pair, and this is another pair, and this is the 4th pair, and this is the 4th pair. So look at here, between the one thing is here link 1 is fixed. You are aware of it. If you want to get a mechanism, we have to fix one of the link in a kinematic chain, then only it provides a mechanism. So here I have taken like link 1 is fixed. link 1 is fixed. So then link 2, link 3, link 4, 1 and 2 forms one turning pair. 1 and 2 forms turning pair. Then 2 and 3 links another turning pair. Then 3 and 4 it forms another turning pair. Then finally 4 and 1 which forms a sliding pair. So that is why it is having one sliding pair and 3 turning pairs. You can see 1 and 2, this is one turning pair, 2 and 3 another turning pair, 3 and 4 another turning pair, finally 1 and 4 one sliding pair. So this is the one of the basic mechanism in a slider crank chain where a rotary motion is converted into reciprocating motion by fixing the link 1. Okay, so you can fix link 2, link 3, link 4 to get various other mechanisms or various inversions of this single slider crank chain, and we will see one by one and its practical application. Let us first focus link 1 is fixed, that is the diagram which it is showing. First, same thing which I have stated, I have shown in a separate diagram. What happens if I fix link 1? What happens if I fix link 2? What happens fixing 3 and 4? So the same basic 4-bar chain, a single slider crank chain, isn't it? Shown like in a different 4 situations, link 1 is fixed. So when I fix link 1, then in this case, so this gives input is crank rotation and output, that is slider translation. That is the first one which just now we have discussed. And the second one is the link 2 is fixed. You can see the link 2. So when I fix the link 2, so the slider block has a complex motion. This is the slider block. We'll see a bit later its application in a Whitworth quick return motion mechanism in detail. So when I fix link 2, then this slider will have a complex motion. Now the third one, when I fix the link 3, isn't it? Then the slider block will rotate. And finally, what I can do, I can fix the slider block itself. Link 4, slider block itself. Then it gives the last inversion of single slider crank chain. Okay, so in this case, slider block is made stationary. You can see here, first we fix the link 1, then input is given to the link 2, and the output is obtained from the link 4, that is sliding motion. This is the first inversion. Second inversion, the crank is fixed, then we have given input at 3, and at that time the slider will have a complex motion, so that is the second inversion. Third one, link 3 is fixed, then the slider block will rotate, that is the third inversion. The fourth inversion is the slider block itself is fixed, then we'll get the last inversion, slider block fixing last inversion. Okay, let us see the practical applications of those things which we have discussed. So this is the basic mechanism which I have shown, a single slider crank chain. So you can see here the animation showing the crank is rotating, and this coupler which we call connecting rod is oscillating. Okay, and finally the slider is reciprocating. So this basic mechanism is used in many number of applications. Let me take two simple examples. One is a reciprocating engine and another one is a reciprocating compressor. A reciprocating engine and reciprocating compressor. You can see here, once again there is an animation simultaneously. It's a pictorial view and it's a two-dimensional view. So this crank is here shown in this yellow colored disc. This crank, in real life, you don't see simply links means like these lines. We don't see like a line as some part of the mechanism. For our simplicity, we convert those things into a line diagram. So here there is a disc. Here you can see there is a disc which is yellow in color. This can be represented by a line like this, crank line. Now that crank is connected to another link which is called coupler or connecting rod. You can see here this is oscillating. So with the oscillation of this coupling rod or connecting rod, you can see there is a reciprocating motion that is taking place by the piston. And here this is the cylinder which is constant, which is link number 1. So the same thing you can observe here. This is actual practical case where you can see in an IC engine, this is the piston, cylinder and crank, okay, crankshaft. So this entire thing is taken as a single link, okay. Then this conversion of rotary into reciprocating, that is a reciprocating engine, or we call it as an IC engine, internal combustion engine. The basic mechanism here is the IC engine, internal combustion engine. Okay, similar, the other example I will show you here is a compressor. So here also the same mechanism is used, but the application is different. The objective of here is we want to compress some of the gases or some of the medium for some specific purpose. Like you can take a simple example like air compressor, which we use to pump the air in your tires and tubes in your automobile applications. You can see the same thing here. There is a compressor cylinder is shown, okay, and this is the actual practically what you see. We store the compressed air in this one. That is not shown here, it is just shown it is a discharge. So the same mechanism here I kept. This is the crank, this is the connecting rod, and this is the piston, okay, and sliding. Here some gas is entered or some air or whatever it may sucked through this and it is compressed and it is delivered through a discharge valve. So both of these, reciprocating engine like an IC engine and reciprocating compressor, uses the mechanism of 4-bar chain, single slider crank chain, that is by fixing the link 1. Link 1 is fixed. You can see this is the basic mechanism where I have fixed link 1. Okay. So now I will change the fixation of the link. Instead of 1, I will move to the second link. Then what mechanism we get and how we can observe this, let us see. As we have already discussed, a fixation of various links will give different inversions of mechanism. Now instead of fixing link 1 in that basic mechanism, I have fixed link 2 and just I have changed the orientation. The mechanism is not changed. Earlier we have this one horizontal and this 2 is inclined. whereas now it is shown 2 is vertical and 1 is inclined. Only the thing is the mechanism is tilted by an angle, and there is a slider here at 4. So this is the one of the beautiful mechanism, that is the second inversion of a single slider crank chain, which results 2 mechanisms named as a Whitworth quick return mechanism, and another one is a rotary engine. Whitworth quick return mechanism and another one is a rotary engine. Okay. So here I will show you the same thing in the mechanism, like this is the link 2, this is the link 3, this is the link 1, and slider is 4. So don't consider these 5 and 6 as a part of it, and don't call it as a 6-link mechanism. So the output of the 4th link we are taking for our consideration, but the actual mechanism is the application of single slider crank chain to a particular purpose. That is why I will focus on up to the 4th link only. Of course you have 5th link and 6th link also, it is there. Okay. So before I enter into this particular practical and actual diagram, what it indicates, let us have why we need a quick return mechanism, or what is quick return mechanism. Let us first discuss in general things which we are aware of it, then we can go for a machine called either shaper or a planer or whatever the machine. Practically we use this mechanism. So let us take a very, very simple example. You are hammering a iron rod for blacksmithy, or you are cutting wood by means of an axe, or you are washing the clothes by hitting the cloth to the stone. Like various examples I said, all these 3 examples I have taken such a way that the human is lifting something and striking it, whether it is cutting the wood, or whether it is washing the cloth, or whether it is any other thing, forging or whatever it may be. So you are just dropping your hammer like this, and once the job is over, you have to lift this to the back position. Then only you can give once again the another hit. Is it? So if you just strike an iron rod by hitting like this, you cannot hit the second hit without lifting this. Isn't it? You cannot hit it once again simply like this. Even if you do like this, it will not flatten, because you need some potential energy. Then this potential energy is converted into kinetic energy. So, but in the other way, if I say my actual work is doing in this process, hitting, when I am lifting it, no work is going to be carried by this hammer, isn't it? But if you don't have this reverse one, this job will not be completed, isn't it? So my objective will be, if I spend more time in hitting and if I lift it in a smaller time, then I can save my time, isn't it? So that is a quick return motion mechanism, which is also needed in a cutting process in a machine tools, where the forward stroke is cutting and return stroke is idle. So I'll take a simple example. You are cutting onion or a vegetable with a knife, isn't it? So you are cutting one slice like this, and if you want to cut once again, you have to move it, then you have to cut it, or you have to lift it and you have to cut it. So the second stroke or the next operation is going to be completed by keeping the first operation in the ideal stroke. So here also the same thing in a Whitworth quick return motion mechanism. the same thing is needed. How we obtain this, we will see. And another one is a rotary engine. Of course, this is entirely different from this. So that we will discuss separately. First, we will see how this Whitworth quick return mechanism will work. Okay. So here I will show first one animation. Then I will come back to this to explain what is happening. So the same thing which I have shown, that diagram is kept under colors to distinguish. Okay, so the practical case as shown here, I will come back once again. Yeah, so you can see here there is an animation going on. So you can see in the cutting stroke, okay, and in the return stroke, what is happening. So this animation also you can observe. So there is a cutting tool. There is a cutting tool which is causing cutting action by moving your cutter. So there will be a forward stroke and a return stroke. So one is a crank and slotted lever mechanism. Another one is a Whitworth quick return motion mechanism. So how we look at this, let us come back. The basic mechanism. Look at here, this is the link 2 is fixed. So this is the link 2. Link 2 is fixed. Link 2 is fixed. So let me put it with a red color so that that is fixed. Now link 3, this is the link 3, and slider is the link 4, and this is the link 1. You can see here there are two circles. One circle related to this center B with third link which is revolving, forming a circle, that is this circle. This is the circle. That is for with the rotation of the third link. Then you can also observe there is one more circle that is corresponding to with A center, AD radius, there is one more circle that forms like this. So I have distinguished one with a green color, one is with a red color, saying the third link forming a red color circle, and the link 1 extension is forming another circle which is shown with a green color. So what is happening, let us see here. And the link 5 is connected to link 1, and at the end of link 5 there is a link 6 is there which is called tool. Now let us take this. Now if I assume like this extreme position, that means when this tool is at E1, when this tool is at E1, then this link D is at D1. Okay, then this C is at C1. So D1, C1, E1 is one of the extreme position. Okay, now I am rotating this in an anti-clockwise direction. This is the direction of anti-clockwise. So when I rotate this in anti-clockwise direction, then I am going to move this path to such a way that this is moving like this, that is C1 to C2 via B. C1 to C2 through B. C1 to C2 through B. It makes an angle alpha angle. It makes an angle alpha, that is at B. So at that time your tool is moving from E1 to E2. Your tool is moving, when I move it like this, C1 to C2, the tool is moving from E1 to E2. Tool moves from E1 to E2. E1 to E2. Then it makes an angle alpha. So next, subsequently, in the next, so when this C2 to C1, C2 to C1 through A, C2 to C1 through A, then it makes an angle of beta. It makes an angle of beta. That means the tool is moving from E2 to E1. E2 to E1. Earlier E1 to E2, now E2 to E1. See, literally there is no difference. That is, when it moves from E1 to E2, E2 to E1, it moves same amount of the distance. So this also same distance, this is also same distance, isn't it? So a simple, in your matrix, you know this one. Simple numbers A plus B, say, which gives some value, but B plus A will not give the same value in matrix. A plus B is not equal to B plus A. A into B is not equal to B into A. Not plus. A into B is not equal to B into A. Even though A and B and B and A having the same values. Similar, it moves E1 to E2. The distance is say X. Then it moves X2 to E2 to E1. That is also X. Distance is concerned same. But the time taking to complete this operation is not same. It is function of these angles alpha and beta. If you check it here, alpha is greater than beta. You check it here, alpha is greater than beta. That means to finish your forward stroke, it takes more time, and to finish your return stroke, it takes less time. So we'll spare one complete lecture solving the problems based upon these concepts. We'll do a separate lecture. We'll spend separate 1 hour slot for that. Now we'll only discuss the theory part time being. So time of cutting by time of return, or time of action by time of idle, is function of these angles alpha and beta. So forward stroke, that is moving from C1 to C2 through B, will cause an angular movement of alpha which needs more time, and whereas moving C2 to C1 through A takes an angle beta, even though the linear distance is same, the time required is different, which we need it for a mechanism called quick return motion mechanism. return should be quick. The name itself is saying. It is Whitworth, a person who has developed this mechanism based on his name. Subsequently, it is called Whitworth quick return mechanism. So this is one of the beautiful inversion of single slider crank chain by fixing the second link. Okay. Now let us see what is a rotary engine, how we can apply this mechanism to there. So the same whatever I have explained with showing different colors, it is also made here. You can see the same diagram like C dash, okay, D dash and E dash. C dash, D dash and E dash, and D double dash, C double dash and E double dash. So one you can observe here, when D double dash, C double dash, E double dash is the extreme left. When I am revolving it, then it is becoming C dash, D dash and E dash, isn't it? So the same thing which I have explained here, you can observe here with clear cut colors shown. D color is shown for this movement and C color is shown for the movement of this, and E color and E slider is shown. Okay. This animation we have already observed. Yeah. This is the another inversion of single threaded crank chain by fixing the link number 2. So same thing, link 2 is fixed, link 3 is rotating, and the link 1 is also rotating at the end. An engine called a rotary engine, where you can observe there are n number of connecting rods, n number of pistons, but one crank. This is the one crank. So that is nothing but link number 2. This is the link number 2. Exactly what here we have shown, that is this one. So they are all connected by various connecting rod and these pistons. So you take only one in your mind to recall that mechanism to here. This is one link and this is another link. Say this is the link number 2, this is link number 3, this is link number 4, and this is the link number 1. So of course the numbering he has given a different one. Cylinder 1 is given, then piston is named as a 3, connecting rod as a 4. Okay, no problem. This is 3 and this is 4. So cylinder is 1 and 2 is crank and 3 is shown as a piston and 4th one is a connecting rod. 4th one is a connecting rod. You can see here 2. Okay. Then 1, that is the cylinder. Then 3rd one is your piston and 4th one is your connecting rod. Now in this case, what happens? When the pistons are moving in and out, the entire engine is going to be revolved. The entire engine is going to be revolved. Okay. So the videos, n number of videos are available in YouTube. You can watch any one of the video. You can easily observe this. By moving these pistons inside the cylinder, the entire engine is rotating. Okay. So the animation I could not incorporate it here, and I can show various process how it happened. It is animating beautifully. So you can see here the entire engine is revolving. You can observe here various operations here like power stroke, exhaust, and suction and compression. Of course, you are in 2-2 course. I think in this semester or next semester you will be dealing with the IC engines. That time you will realize what is power stroke, what is exhaust stroke, what is suction, and what is compression. You can see here what is happening. The entire engine is revolving. That is a rotary engine. Okay, so where the entire mechanism or the entire cylinder is revolving. So this is motion is given to propeller. That is what he mean to show, because these are the blades or whatever you call it, driving one. The entire power is given to this propeller. So this is the another inversion for single slider crank chain by fixing the link number 2. I hope I can stop this animation. It will go on some more time. It is enough for us to understand. Okay. Now let me go for the third inversion. Okay, this is the inversion. Once again, similar to your previous quick return motion mechanism. So, but here, this is slotted lever mechanism, slotted crank mechanism. And another application is an oscillatory engine. Already we have discussed just now what is a quick return motion mechanism, where we use, how it is going to be used. So, this is a practical application in a shaper machine. Just now what we have discussed, the angle which is made with the forward stroke and return stroke, and you can see forward stroke is more angle and return stroke is less angle. But only the thing is here, the link 2 instead of fixing link 3 is fixed. You can see there. Link 3 is fixed. In the previous case, link 2 is fixed. Now it is link 3 is fixed. So the same thing is shown in practically how it looks. Link 3 is fixed, and now where we give input, say link 2. Then we can observe the movement of link 4, and of course here also you will get 6 linkages. My objective is finally the output of the 4th link is given to the 5th link. So don't take it as a 6-bar linkage mechanism, it is a 4-bar link mechanism only. So 3rd link is fixed and the second one is rotated. When you rotate the second link, then this slider, that is the slider, is reciprocating in a slotted lever. This is called lever. Recall yesterday's lecture, what we called a lever. Lever is one which oscillates. That means in this mechanism, when this crank rotates, then this lever oscillates. So these are the two extreme positions you can see here. There is one more diagram I am clearly showing it. So this is one extreme position and this is the another extreme position. So this rotation of this crank is causing an oscillation of this lever between these two levers. The end of the lever is connected to another link or a coupler which causes the reciprocation of the tool. Okay, so here also the same thing, forward stroke will be completed with a more time and return stroke will be completed in the less time. So this is also similar to your second inversion where Whitworth quick return motion mechanism, but where both link 2 and link 3 and 4 rotates. Here it is not that way. The link crank is rotating and this lever is oscillating. Okay, so we will distinguish the differences of slotted link crank mechanism and Whitworth cricket motion mechanism separately when we solve the problems. So this is another inversion which is named as slotted lever crank mechanism. So slotted lever, this lever will have a slot, you can see here. It will have a slot. So in this slot, isn't it? So your sliding black, that is this, is rotating as well as reciprocating. Here there is a crank which is rotating, and here there is a sliding black which is reciprocating. Finally, the end of this lever, you have one more link which causing a reciprocating motion to your machine. This is a practical case where we use this mechanism. The tool moves from one end to the other end forward, that is the theta angle, and in the return, that is taken a beta angle. So you can see the diagram, theta is greater than beta. Naturally, forward stroke takes more time and return stroke takes less time. Then the other application is oscillatory engine. It's very simple. You can see the animation, you can easily identify it. So I have fixed the link 3. The same diagram is shown here as it is how the diagram is available. Now you can see this link 3 is fixed, then link 2 is revolving, then you can see there is a sliding motion to this piston, then entire cylinder is oscillating, you can observe. So this is green one, crank, which is rotating, and you can see the piston which is sliding. Then your cylinder is pivoted at one point, so cylinder is oscillating. You can observe here, you can see here when the link 3 is fixed, then the connecting rod which is link 3, this is the connecting rod which is fixed, causing the reciprocation of this and the oscillation of this cylinder, that is the oscillatory engine. And finally, the last inversion is by fixing the slider, which uses a simple hand pump. It's a beautiful application of your inversion of a single slider crank chain, where your piston is restrained, that is motion of the slider is restrained. So the same mechanism you can see here, orientation change 1, 2, 3, 4. Okay, the same thing I have shown here in actual pump. So here the fourth one is the piston, that movement is restrained, that is the slider movement is restrained, and here link 1, this one, then this is the link 2, and this is link 3, and this is 4. So here majority of the times students will get doubt. So what is actually these links here in this reality? So this is link 1. This rod is link 1. So don't consider this piston, bottom slider is another link. There is no relative motion between this. So that's why they made it as a different colors. Look at the colors is concerned. This is color 1, is a single link. Then this is the lever. So this is the lever which is here, exactly this one. So there is no relative motion between this entire lever, that is the link 2. Then the third one is this one. Here, whatever it is shown as a line, there is no line at all here, only the pin. Here the colors are very important thing. This is a white color. So the white color one which is showing as the link 3, and finally link 4 is a green color. You can observe here 4 colors. So the one is a violet color, violet color is 1, then that is the link 1. Then coming to the say that is a black, which is second link, then white is a third link, then green is the fourth link. There is a fixed link. This is fixed. So green link, green colored one, that is the casing is not moving, it is restrained. So this is the fourth inversion of single slider crank chain. Okay. So with respect to your end examination, this is very important one. Definitely any one set we get definite an essay question on this. So we'll see in another lecture by incorporating problems and comparison of the Whitworth quick return motion mechanism as well as the crank and slotted lever mechanism. Once we finish the entire topic, then I will enter into that area. So let me summarize in 2 minutes. The first one is by fixing the link 1. We get 2 applications, IC engine and compressor. Then by fixing the link 2, we get 2 inversions named as Whitworth quick return motion mechanism and a rotary engine. Third one, by fixing the link 3, we get crank and slotted lever mechanism and oscillatory cylinder. And finally fourth one, by fixing the slider, that is we get a hand pump which is lively available here. Okay. So with this, we'll conclude today's lecture. Thank you.